Assalamualaikum, good day everyone. My name is Mohamad bin Muhammad Sabri and I'm presenting the result on behalf of my co-author Jamaluddin Mohamad, Fadlizil Faris, Muhammad Zikri Muhammad Zaki from Universiti Teknologi Mara. This title of this research is Architecture Facade Aerodynamics in Culture Form, Design Investigation of a World Heritage Center and Craft Center in Kelantan. This study explores how aerodynamic facade strategies can be integrated with culture architecture expression, particularly through the expression of traditional wall bulan. To briefly introduce the research team, this study was conducted collaboratively by research from the Department of Built Environment Study and Technology, Universiti Teknologi Mara, Syed Iskandar. Each author contributes to all aspects of the research, including theoretical development, case study analysis, and design investigation. To begin the discussion, let us first look at the background of this study. The selected site for this research is Pantai Cahaya Bulan in Kelantan, which is located in tropical coastal environment. Buildings in this region are exposed to strong coastal wind and high humidity level. In addition, environmental factors such as wind-driven rain, pressure fluctuations significantly affect building envelope performance. Because of this condition, there is a growing need for responsive facade system that can adapt to these environmental challenges. Then, introduction: facade as environmental interface. Building on this environmental context, it is important to understand the role of the facade in architecture design. Facades are no longer viewed only as aesthetic elements. Instead, they function as environmental mediator between the interior and exterior environments. They regulate airflow, control heat exchange, manage pressure difference, and ultimately influence building energy consumption. Then, introduction: tropical coastal dynamics. In tropical coastal region, environmental conditions are shaped by monsoon wind cycle, intense solar radiation, and high humidity levels. These factors create turbulence and stagnation zones around building surfaces. However, when carefully integrated into architecture design, these same environment forces can also support passive ventilation and cooling strategies. For the problem statement, despite the importance of facade performance, existing research tend to treat two areas separately. Aerodynamic study often focus on technical performance such as wind flow behavior and pressure distribution. Meanwhile, culture architecture research tend to emphasize symbolic or aesthetic representation. As a result, there is a lack of integration between environmental performance and culture architecture design. For the research gap, when reviewing the literature, a clear gap becomes visible. There is disconnect between building physical research and culturally informed architectural design. Although traditional architects contain valuable environmental knowledge, this vernacular intelligence is rarely translated into modern aerodynamic facade strategies. This gap formed the main motivation for the research presented in this study. Research aim and objective. In response to this gap, the aim of this research is to develop an environmental morphological framework that integrates aerodynamic principles with cultural architecture form. In particular, the wabulan, a traditional Malay kite, is interpreted as a form of environmental intelligence rather than purely cultural symbolism. Through a research by design approach, its morphological characteristics are translated into architecture facade strategies. Then, theoretical foundation. The theoretical foundation of this study integrates several key concepts. This includes aerodynamic morphology, wind pressure modulation, permeability, collaboration, and phasis ventilation principles. Together, this concept treat the building facade as an active environment system capable of improving airflow and environmental performance. Moving on, with building interaction. Understanding wind behavior around buildings is essential for aerodynamic facade design. When building interacts with building surface, it produces stagnation pressure zone, vortex shading, and airflow suppression. So, the research show that curved or inclined form can redistribute wind pressure and reduce turbulence, allowing airflow to move smoothly around the building. After that, cultural morphology, wow intelligence. At this point, we turn to the cultural inspiration of this study, which is the wow bulan. The structure of the wow demonstrates curvature, structural tension balance, layer construction, and calibrate permeability. These characteristics enable the kite to remain stable while interacting with wind force. Because of aerodynamic behavior, the wow can be interpreted as a transfer environmental model for architectural design. For methodology, to investigate this idea, the research follow a three-phase methodology. The first phase involves literature synthesis to identify relevant aerodynamic and environment principles. The second phase consists of case study analysis of the selected building that demonstrate aerodynamic facade strategies. Finally, the third phase uses a research by design approach to translate this finding into architectural design strategies. From here, case study analysis. 3 architecture case studies were selected to explore different aerodynamic strategies. First, the Diamond building in Putrajaya demonstrates the inclined geometric surface that reflect wind pressure. Then, the Malaysia International Trade and Exhibition Centre, or MITEC, demonstrate layer facade system that enhance ventilation. Finally, the Haidar Ali Culture Centre by Zaha Hadid demonstrate the aerodynamic benefit of continuity curvature in architecture design. Following this, cross-case synthesis. When comparing these case studies, several important design principles emerge. First, inclined building form help reduce stagnation pressure zone. Then, layer facade system help improve ventilation performance. And continuous curvature help stabilize a flow pattern around the building envelope. For research by design translation, based on this finding, the research translates wow morphology into architectural strategies. This process involves curvature modulation, permeability calibration, surface continuity, and cultural interpretation amended within performance logics. The transformation diagram show how the wow form evolve into architecture machine and facade articulation. For the environmental and cultural strategies, the proposed design strategy integrate wind response meshing, building orientation aligned with monsonal wind direction, and pressure-driven airflow channels. Through the approach, cultural architectural expression is not as simply decorative, but become embedded with the environmental performance strategies. Let us now look at the contribution and recommendation. This research make 3 main contributions. First, it proposes an environmental morphological framework for aerodynamic facade design. Second, it bridges the gap between building physical research and cultural architecture expression. Third, it introduces transfer wind response architecture principle for tropical environment. For the future research, further studies are recommended, including CDF simulation, material optimization, and full-scale prototyping. To conclude, facade systems should be understood as active environment mediators rather than passive building elements. This research demonstrates that wow morphology can function as performance-driven environment intelligence. By integrating aerodynamic principles with cultural architecture expression, architects can develop resilient and sustainable design for tropical coastal environments. Finally, I would like to thank you for your attention. I truly appreciate the opportunity to present the research.